This is from Smart Editions, and this is the new drag and drop, put them in order. But y'all, if you're taking the T6, you're still going to have to pick multiple choice answers for questions that are asking you to put numbers in a certain order. But this is T6 and T7. We want to put these numbers from greatest to least. And John mentioned earlier, take these fractions, or even if you have percents, convert them to decimals and use your calculator. I am going to cover several calculator tips with you all today. Just be careful with the negatives here. So all we're going to do for a fraction to convert it to a decimal, take the top number, for example, -5/10. That's going to be a half, but if you take 5 divided by 10, you get 0.5. So I want to think of this as -50 cents. Think about money. So I'm going to put a little dollar symbol there. And I added an extra zero, no big deal there. You can add as many zeros as you want to the end of a decimal. And if I just press equals, notice that it is still 0.5. So this one here is no need to convert this to a decimal. It already is. And this is actually somewhere roughly around a penny, because that 2 tells that 1 to stay the same, roughly 1 cent. And that could be enough to just get us by on that. 16 divided by 36, some of these will have long decimals, as you can see right there. So 16 divided by 36, this is approximately 44 cents. Continuing on, -5 divided by 9. We can take that 5, divide it by 9, and this, if you technically round this, to the nearest penny, this is going to be approximately -56 cents. I know you see a bunch of 5s, but if you round to the nearest cent, which is what computers do all the time when you're checking out groceries or if you're buying a dinner or whatever, that hundredths place, the nearest cent is always rounded. So that's roughly -56 cents. And then this one right here, 5 divided by 8, we get 0.625. And if you round that to the nearest cent, we get somewhere around approximately 63 cents. So, even though we're talking about fractions and decimals and all that stuff, I mean, look, we're talking about rounding as well. If you have to round something to the nearest cent, 2 decimal places. So now let's just make sure we don't mess this up. Let's go greatest to least. So we definitely don't want to pick any of these negative ones. And if we look, 63 cents, unless I messed up somewhere, 63 cents appears to be the biggest one. So therefore 5/8 is the greatest. The next one is going to be the 44 cents. So that's going to be the 16 over 36. Keep on going. Let's see. Now, how about a penny? We got that 1 cent right there. So that is that 0.0125. And now be careful with your negative numbers, y'all. The negative numbers, think about negative money. I mean, listen to this. Would you rather be -$100 in your bank account or just -$1? -100 is a lot less than -1. -100, that's less. That is smaller than -1. So technically, -50 cents is going to be the one there. All right, now we only have one left, and this is going to be the smallest one, the -56 cents. There is no dollar amount, and I should have wrote that as -5 over 10 just to stay consistent with the way it was given. So, thinking about money, be careful with the negative numbers. The more negative a number is, the smaller it is. And think about money. That's the best way I can explain that to you. So, even though, we have to actually drag and drop these. So, let me just shoot that guy over here and shoot this one over here. Greatest to least, I'm just going to go ahead and drag these. This is from Smart Edition again. So, dragging that down, and I'm just going to keep on going. And with this, it kind of goes without mentioning, with this drag and drop and hot spots, y'all, these tests are no longer going to be paper-based. I mean, that's the only way you're going to be able to drag stuff. So checking that one, and that's instant feedback over at Smart Edition. So this is one of the new Test question types, drag and drop. Again, this is still applicable to the TEAS 6 because you are going to have multiple choice questions that ask you to put put a list of numbers in a certain order. All right, now, so let me jump to a fill in the blank. And I tell you what, here's what we're going to do, y'all. Let's make it a little bit interactive. I want to give y'all some time to read the question. This is what I do in my mini sessions, by the way. I do teach mini sessions with 10 students or less. It's all through Google Meet. So what I do in these mini sessions is I have problems pre-made and I put it up here on the screen, make that a little bit bigger, and I let students work these out. So here's what I'm gonna do. I'm gonna give you a minute and 30 seconds. This is fill in the blank. Feel free to come in on the Facebook group chat, the Google Meet chat, a minute and 30 seconds. I'll be back. I wanna see what answers y'all get. All right, so I did see some answers coming in over on Google Meet. Perfect, eating it up with the 912, and 912 is right. Fill in the blank, what you want to leave off. I'm gonna go ahead and show that to you. I'm still gonna work this out with you all, but notice it does say round to the nearest dollar. Do not include a dollar sign, a comma, nor a decimal. So basically just the digits 912, since a lot of us are saying that's the answer. Check it out, it is correct. Notice over at Smart Edition and as well as the resources I'm gonna show you that I have, you do get explanations as well if you do get an answer right or wrong. But let's work this one out. There's a lot of, I guess you could say, filler or distractors when it comes to some word problems. Obviously a phone number does not matter even though we see numbers. And here we have to pay attention to the days, assuming you read the problem. Tuesday, Wednesday, Thursday, and Friday. So there's 4 days a week and from 10 a.m. to 6 p.m. So let's look at that. 4 days, and each of those 4 days from 10 a.m. to 6 p.m. there's 8-hour shifts. Now the hourly rate is going to be $14.25. And be careful, we want to figure out the gross pay in 2 weeks, not 1 week, but 2 weeks. So this is really just a long multiplication problem, in all honesty. It doesn't matter what order you multiply, y'all. Multiplication does not matter which way you multiply. Let's just take the 4 days. If you work 4 days and you work 8 hours each shift times 8, that's going to be 32 hours per week. I'm going to go ahead and double that since the question says 2 weeks. So that's a total of 64 hours. So this is the total number of hours, 4 days a week, 8 hours each day for 2 weeks, 64 hours. And the hourly rate is going to be $14.25. So you can multiply by $14.25 and we do get that 912. Again, it does not matter what order you technically multiplied here. As a matter of fact, you could do all of this at one time. I mean, I can take it totally random. We can take the 1425. We can multiply that by 8 hours times 4 days a week times 2 weeks. We still get 912. Multiplication, it does not matter what order you multiply. All right, so that is 2 examples from Smart Edition, drag and drop or rearrange, as well as fill in the blank. And now the math review. I've just made a small T7 sample. I'm gonna work out 2 of these from here. Now, I haven't really heard, let me make this a little bit bigger so y'all can see that. Check all that apply, even if this does not pop up on the T7, like check all that apply. I think it's still worth knowing because essentially, like John mentioned earlier, when you're checking all that apply, consider it a different example for each one. Technically, we got 6 different things. Read the question carefully. It says which statements are true. And I'm just going to shoot that over here. Again, I will share these notes with everybody. Take a minute and a half. And I guess a way you could leave the answer, you could say, you know, we'll call this A, B, C, D, E, and F. Feel free to type in the letters for the ones that are true. I'll be back in a minute and a half. So again, treat each one as its own separate example. This kind of goes back to where we were converting things to decimals, thinking about money. Think of decimals as the most common form of a number that we deal with. probably from day-to-day life, decimal forms of numbers. When we deal with money, that's decimal form. So we have fractions, we have decimals, and we have percents. So this one right here, if we think of this in terms of money, this would be negative $5. And Pac-Man, this means greater than. Think about it like a Pac-Man or an alligator, and you want that mouth to be eating the bigger number for it to be true. So, is negative $5 greater than negative $5.10? And remember, I mentioned earlier about the negative numbers. The negative numbers. The more negative a number is, the smaller it is. So yes, negative $5 is greater than, that's what that inequality means, negative $5.10. So this one is true. Let's move on along. If you don't have decimals, like 82%, now folks, two ways we can do this. You can either take your percentage, 82%, you can divide it by 100. This is a way that you can always convert a percent to a decimal. Take your percentage, divide it by 100, and some of y'all probably have heard of moving the decimal 2 places to the left. D2P is something that I've used in my videos. So therefore, 82%, I'm going to think of that as 82 cents. Is this greater than or equal to? That little line right there. Greater than or equal to. And let's take 41 divided by 50. Check it out. We get the same exact thing. So sure, it's not greater than, but it is equal to. So this is still a true statement because of that little itty bitty line right there. Had that line not been there, it would have been false. Now, very similar for the next one here, 7 divided by 2. That's going to give you $3.50. If you take $7 and you break it up into 2 piles, that's going to be $3.50. Is that greater than 250%? You need to convert your percent to a decimal. That way we can compare all of these numbers. So again, just to rehash on that, take your percentage, divide by 100. That's how you always convert a percent to a decimal. So that's $2.50. So right now, these first 3 are all true. Now let's look at these other ones. Negative $20? No, that is not less than negative $100. Negative $20 is actually bigger. So this one is false. 2.5%, if we convert this, 2.5% is going to be 0.025, 2.5%, divide it by 100. And let's think about this. What does that round off to roughly? That rounds off to roughly 3 cents if you round to the nearest penny, and that is not less than 0.0025. That's not even a penny, y'all. This right here, that's not even a penny because you got 2 zeros right there. So this one is false as well. And then last but not least, 7 divided by 9, you're going to get 0.77777777, which is roughly 78 cents. And no, that is not greater than 80 cents, adding that extra 0 there. So this one is false as well. So, you know, if you haven't messed with fractions, decimals, and percents, you need to know this. T6, T7, T's 100, I don't care. Knowing how to convert between fractions and decimals and percents is going to be crucial. Now, feel free to come in on the chat with any questions. One more problem that I want to do today. So actually, let me check these and show y'all the feedback. So this is from my math review. You can access this from the quizzes tab. I'm checking those. I'm going to click check. It does say we got these 3 right. And notice, look at my feedback. Try converting all of the problems to decimal form and think about money. It's exactly what I was just talking about. The rest of these, those right there, those are the ones we said are true, and the rest of them are false. So let's do one more. Let's see here. That's another check all that apply. Let me go to Let's do this one right here. This is a conversions problem. So this is a fill in the blank. And let's try this one out. So 1 minute and 30 seconds. This is one more example, and I'll be right back. All right, so this is our last example, but again, if you have time, please stick around because I am going to show you a few calculator shortcuts. I did see some answers coming in. 20 is the correct answer. Let's go ahead. I think it is. Let's go verify that. So if we type in 20, we press check, and notice that is correct. There's an explanation there. And now let me show you how to work this out. So these are some conversions, and a lot of times I hear questions from students. What conversions do I need to know? I think you do need to know that 12 inches is equal to 1 foot. Even though we will not use this one in this problem, 3 feet equals 1 yard. If you know those two, I don't think they're going to ask you to remember feet to miles. But those two conversions I would definitely say are good to know. Since I'm on this roll here, 16 ounces equals 1 pound. Obviously that does not matter for this problem, but that is a conversion that I would recommend that you know as well. And for more of those, we can talk about that over in the Facebook groups. So what you have to recognize here is that the car, each car is 2.25 inches long. And then this train of cars that Jackson is lining up, he's lining up a train of Matchbox cars. That train is 3.75 feet long. Here's the fastest way to do this. The fastest way to do it, in my opinion, is to take those feet, since that's 3.75 feet, you can always multiply feet by 12 to convert to inches. 3.75 times 12, that's 45 inches. But now that we have this long train that's 3.75 feet, which is the same thing as 45 inches, well, since this is inches, let's just divide it by how long one car is. If you think about this, 3.75 feet, 45 inches, it's going to take quite a few cars because each car is only 2.25 inches. That's about shorter than your index finger. Maybe about the length, that's a little bit longer than your pinky finger. Imagine that. So let's divide. That's what we're doing here. We're going to take that 45 inches and we're going to divide it up into 2.25 inches. And we do get 20. Notice right there. So we get 20 cars. So those are the 4 examples. I mean, obviously we're not covering everything. There's some geometry. There's more percentage-based problems. I have plenty of resources over at my website. The things that we're offering at 40% off, you can definitely take advantage of those. Now, what I do want to show you before we go is I do want to show you some calculator tips that they do work. They do work on the on-screen calculator when you're taking the TEAS test. So let me make sure I'm covering everything. All right, so here we go. Now, this calculator over here, this obviously does not look like the TEAS test calculator, but the button layout is pretty daggone similar. Let's talk about square roots. The square root of 25 is equal to 5. You don't divide it by 2. When you find the square root of something, you are finding a number that you can multiply times itself. So here's how you do it on the TEAS test. If you have to take the square root, which is likely you'll have at least one example, type in the number first, then press the square root button, and you may have to press equals on the TEAS test calculator. Mine just automatically spits it out. But that's a quick way that you can test to make sure that you're doing it right. When you grab the TEAS calculator, just say, okay, I'm going to check. 25, square root, you better get 5. So with that said, we can now do funky problems, like the square root of 50. The square root of 50 is not 25. As a matter of fact, it's going to be a little bit bigger than 7 if you think about it. Because 7 times 7 is 49. So we got to go a little bit bigger than 7 times 7 because 49 is just below 50. Let's type it in. Type your number first, bang on that square root button, and as you can see here, it is just a little bit bigger than 7. Rock and roll. So that's the square root button. Now, here, okay, the percent key. The percent key, now the TEAS calculator does have one. Some calculators don't have a percent button. Always remember that you can technically convert a percent to a decimal by dividing by 100. So 25%, for example, is 25 over 100, and that's going to be 0.25. So it's kind of like you got your fraction, you have your decimal, you have your percent. Well, when you're dealing with sales tax, let me just make up an example. So my question would be, what was your subtotal? And basically this means what was the price of the groceries before tax? That's what subtotal means. What I want to show you here. Now, if this was a fill in the blank, you don't have multiple choice questions to go off of. But I'm going to go ahead and I just want to show y'all how we can quickly do this. If this was multiple choice. What you don't want to do is this, y'all. I see $124.05 coming in. What you're doing there is you're multiplying the 6% by the price, which already includes the tax. And that's not what we want to do here. You actually want to take the subtotal. This is how tax is computed, y'all. You take the subtotal, you take the price before tax. Look at this $124.50. If we take $124.50 and you multiply it by 6%, you are finding the tax that is on the price before tax. And that's what you want to do here. So watch this. If I take $124.50 and we find 6% of that, which is 0.06, we get $7.47. You don't multiply the sales tax percentage by the total price of the groceries if that includes tax. That's not how it's done. You multiply 6% or whatever the sales tax rate is by the subtotal, the price before tax. Now check out what happens if we take the $124.50 and we add on that sales tax. So I'm just going to take the $7.47, add on the $124.50, and here we do get $131.97. So it's not $124.05. I could see why you'd want to pick that, but again, you don't want to find 6% of this price because that price already includes the tax. That's the tricky part there. Now, what does this have to do with the shortcut on the TEAS calculator? Well, watch this. Some calculators with a percent button don't do this, but the TEAS calculator does, I promise. What we can do if it's multiple choice, watch what I'm going to do here. On the TEAS calculator, type in that subtotal. And again, not all calculators do this, so don't get mad if you're doing it on another calculator with a percent button and it don't work. I'm here to tell you it will work on the TEAS calculator. All we have to do is add, and I'm going to type in 6%, and look at what it does. This does not work on all calculators with a percent button. It works on this one, and it works on the TEAS test. What the calculator's doing in the background is it's taking that $124.50. Let me copy this over and make it bigger. What it's doing in the background is it's taking this calculator here and the TEAS calculator. It's taking 6% of whatever this number is, and it's going to add it to it to give you that. So that is a fast way without you having to do two separate steps. You don't have to find 6% first and then add it on, though you can always do that still. That works on any calculator. I don't care what you're dealing with. You can always do it the way I did it here. All right, so I said I was going to shut up, but I mean, people are asking, what if this is fill in the blank? Now, y'all, I could get into a 20-minute conversation about this, and I'm not going to do that. But here's what you got to think about. You take the subtotal plus the tax, and this is going to be equal to the, I guess you could say the grand total. I'm just going to call it the total. Technically, the word total means the subtotal and the tax together. So let's act like we didn't know these answer choices. Let's act like it was fill in the blank. We don't know the subtotal. We don't have these answer choices. Well, I'm going to put an X for that. I don't know what the subtotal is. Sure we do, it's right there, but let's act like we don't. Plus sales tax. How did we find this sales tax up here? How did we do that, y'all? We found 6% of the subtotal. That is how you find sales tax. This is how you find tips. This is how you find discounts. 6% of the subtotal. Here's what that looks like algebraically. 6%, don't leave it like that, because it's not just 6 cents, y'all. It's 6% of that subtotal that we don't know. So that's why I'm going to put an X right there. I know that throws people for a loop, but that is how you find sales tax. The percentage, 6%, times that X value, which was that subtotal. Now we can come in here and set this equal to 130,197. And to kind of end things here, I'm tying in some algebra. Combining like terms, this is an understood 1. So if we combine like terms, we get 1.06x is equal to 131.97. And last but not least, to solve this equation, you need to brush up on equations as well. I know we didn't do a lot today, but you definitely want to know how to solve these. Let's take that 131.97, let's divide by 1.06, and there's that 124.50 yet again. So multiple approaches, multiple choice, fill in the blank, all that good stuff. I hope you find this helpful. If it was hard to see, hard to hear, if I moved too fast, I'm sorry. I am recording this, and Smart Edition John's recording it as well. I'm going to do some edits. I'm going to share the files with you all. But that's my spiel. I hope you find it helpful, and I'm going to turn it back over to John.